What is good, everyone? How's everyone doing tonight? I hope everyone is doing okay. I hope everyone's keeping their head up. I know that there's a lot going on, but I still wanted to stream today just to, make sure, one, so that we didn't fall behind, two, give people a distraction. I thought about canceling because I know a lot of people are still struggling to get home. I live not far from DC at all. I know tons of people who live there. My whole family still lives down there. A lot of people are still, trying to get back into their homes before curfew and everything like that. I understand. Seriously, I just tweeted out, if there's a lot going on, if this is going to be a struggle today, absolutely take the day off, turn it off, relax for a bit. It's going to be recorded. It'll be available for you. You can catch up. Remember what we said the very first day is to not be too hard on yourself. These are the types of things. Life happens while you're trying to learn these things. This is not the only thing going on. Thank you. This is not the only thing going on. So, I completely understand. Do what you have to do. Take care of yourself. Take care of your mental. But I personally am happy to be here with you all today on day 2 of our pipelines journey, our journey into software delivery, automation, and infrastructure, DevOps, and SRE. So how's everyone doing? Second bill and cycle. Like I said, I completely understand, all good, but it's good to see you. Glad you're able to come through for a bit. BPEZ, absolutely, certainly understand. Hang out. We'll probably keep things pretty chill tonight. Especially because of that. We're just gonna be having tonight's honestly gonna be mostly chatting. We'll get a little bit hands-on, but it's a lot of optional things, a lot of just fun things to kind of get us set up for next week. So don't sweat that at all. What's up, Chara? How are you doing? What's up, A? It's always good to see you. What's up, Chisk for Costs? I tried it. I did my best. Welcome, good to have you. Crystallized Code, it's good to see you. Eastside Boy, what's up? How you doing? Lead DevOps, how are you doing? Anyone planning on using AWS for Linux? Good question. You can use AWS for Linux if you'd like. I have tons of other options. A bunch of stuff should have just dropped in your Google Classroom as well. So we're gonna go over some of that, but you can use whatever you like. And that's mostly what we're gonna be talking about. We're gonna be talking about your options, getting set up, getting ready, so that you know what to do going into next week. Yes, it has been a wild day. What's up, Virgil? How are you doing today? Penguin Airlines, absolutely, we could all use a little distraction. Oh, Lead DevOps, you live in the heart of DC. I hope you're good. It's very interesting when I started to think about the fallout of quick decisions for curfews. Like, are people still allowed to order food? What if my plan today was to go to the grocery store after I got off work, and now there's a curfew, I can't go to the grocery store, and are the people who deliver food allowed to deliver food? What are your options there? It's pretty interesting. I feel like it presents a lot of problems, but I hope you're able to get everything sorted out. What's up, Icarus? How are you doing today? What's up, C Sanchez? It's good to see you again as well. Good to have you all here. What's up, Dorian? Good to see you. Pablon, how are you doing? Nitro Sage, really, really good to see you. Manute 83, how are you doing today? What's up, Dylan? How are you doing? GCP with Linux. I've actually never used a GCP. I think it's called App Engine, whatever their default VPS server offering is. Never use it. So maybe one day we'll hop on there. Training using the Linux subsystem for Windows. Absolutely. I'm going to be using, so I do use the Linux subsystem for Windows. I might show people how to get that set up because I'm not sure if it's set up on this computer yet. But yeah, we'll see. Doesn't look like they're enforcing it. Yeah, I don't think they can enforce it. It was too early, to be honest. And I know stuff is still going on. So let's do a performance agreement for work. Okay. I'm happy to report that as a DevOps engineer, I have gone from the bottom of level 0 to exceed. That's amazing. Exceeding your level 1 goals. That is phenomenal. Congratulations, first off. Now your hard work is an inspiration to us all. That's pretty dope. Especially, I think it's even more inspirational because that's the hardest place. That when you're really at that level 0, trying to, feel like you belong and feel like you know things, it's really hard to fight through a lot of that. So that is pretty dope. What's up, iPardon? What's up, Wikaid? How are you doing today? What's up, Soka? It is good to see you. Also, Johnny, look, thank you so much for the follow. So, like I said, today is going to be pretty chill. We got a couple of slides for 2 things. We are going to do an introduction to Git tonight. We will do a little refresh later, so don't sweat it if you can't spend too much time paying attention to it. And this is mostly just so you can start submitting things to GitHub Classroom. Your first GitHub Classroom assignment is going to drop at the beginning of next week, and you don't have to finish it. It's not due day one or anything like that. But you do need to know how to the Git basics so that you can actually submit it. So we'll cover that a little bit. Talk about salaries, have a little conversation about roles and responsibilities. It's very open today. It is very open. So you should have 2 sets of slides in your Google Classroom, and let's head over to the Academy view. Let's see what we got here. All right, load up. So we're in pipelines tonight, and everything looks like it posted. It's weird, you schedule it for 7 and now it's posted a few minutes late. That's fine, but just a few things tonight. There's some Git slides and some regular slides. There's only like 5 regular slides. So like I said, pretty chill. I'm gonna try to get you out of here as quickly as possible this evening. What's up, Aki? How you doing? It's good to see you. Let's see. So let's talk about it. Today's the money day too. We're gonna have a conversation about moolah, and I'm looking for your input as well. This is this money conversation is going to be us just talking about money. So input whatever, feed into the conversation as much as you want. I'm going to prod it along, but let's talk about it. Ask whatever questions you want to ask about it. We're gonna be very open and honest about it. So today is, let's get ready. Hold on, let's get a little echo going. Pipelines, a journey into software engineering. Wait, nope, I got that wrong. Let's start over. Pipelines, a journey into software delivery, automation, and infrastructure. We are on day 2. Good to have you all. So here's the agenda for today. Didn't change. I did not change that. What's that thing called? I'm going to leave that buckle up thing there every week. But we're going to talk about job roles and responsibilities. Very high level conversation about what your roles and responsibilities in DevOps and SRE might be. It's a very light list, and we're gonna expand upon that through conversation. We'll talk about money a little bit. I think I might have had these flip-flops in the actual, when we go past this, but it's fine. We'll talk about money a little bit. Then we'll do a quick introduction to Git, what it is, and we'll get hands-on so you can see how to use it. I'll give some examples. And then we'll do, it says development environment setup. You will see that for this class, there isn't a lot of, there's not a lot of crazy setup that we have to do at all. So we're really just gonna get text editors and things installed. I'll run through how to do the remote development environment if you want to. I wanna give you time to be able to replicate my setup. We did this a little bit last night. This will incorporate a little bit more things. We'll talk about all of your options here as well. And then we'll just ask some questions, so it'll be all cool. Yes, I can share the slides. Copy link. Let's see. Let's go into the chat. Let me log in here. I was gonna just, I do operate off of 2 computers, which is fine. But I do want to be able to send you stuff easily right here. So let me log in really quick. I know that you can see my one-time code. You can see my one-time code. You just can't see 2 in a row. As long as I don't show you 2 in a row, it's completely fine. And we'll do a commands. Edit, what do we have? Slides, and there we go. Hit the exclamation point slides. You can now get there. You're right. There are so many overlaps in the different roles and job postings, and this is why we're gonna have we're just gonna have a conversation about it. I'm glad you caught that for sure. Let's see. But yeah, do exclamation point slides if anyone needs the slides. Should give you the link to it now. Cool. Did I leave? Here we go. We're back and we're ready. Wait. Oh, this isn't supposed to be in there, but whatever. And I guess I did money first. Let's talk roles and responsibilities first, because the money conversation is a little more fun. So I wanna like do that second, to be honest. So let's talk roles and responsibilities first. So, we've had the conversation about what DevOps and site reliability engineering is. We've learned that DevOps, it's a cultural and professional movement that helps high velocity organizations be able to build things faster. We know that DevOps is designed around breaking down those silos between development and operations so that they are communicating more and working together to understand the entire software development cycle. We know that site reliability engineers also they do implement DevOps methodologies often to solve problems in their roles, but their focus is more so of the reliability of the systems. Their focus is the systems, whereas DevOps focus is kind of the development and the delivery of the software. The rest of this course is called, we talk about automation and infrastructure and software delivery. And that there's a lot of pieces that go into both of those. So it can be confusing to kind of understand what are the tangible things that you would do in each of these roles. And that's what we're starting the conversation for right now. So DevOps, here are some primary DevOps roles. Again, this is a very generic list of things. So don't sweat it at all. Trying to figure out, hey, there's things that I thought was going to happen that are missing. Feel free, if you think there's anything that's supposed to be on here, ask questions about it. We can talk about it. But one of the main things is documenting this tribal knowledge and documentation period. I really wanted to leave this one in here. This is actually one for the SRE slide, but I wanted to leave the tribal knowledge in there to talk about that a little bit. So what is tribal knowledge? What is documenting? What is documentation? So tribal knowledge is the type of knowledge you have when you are part of an organization or a group, and it's been existing, it's been growing, things have been happening, and the people who are there, they know these things. They know the history. They know why decisions were made. They understand why things were chosen, and they understand how things work. But this tribal knowledge is things that are known amongst the tribe, known amongst the people, but aren't put anywhere. So it's difficult for anyone else to come into that group and be able to get all of that knowledge. They have to get a piece from over here. And if you want to find out why this is set up this way, you got to go to Doug. And if you want to find out why this decision was made, you got to go ask Sally. And if somebody leaves the company, it becomes very problematic. Okay. And so documenting tribal knowledge was also just documenting the processes. DevOps is about the processes. It's about setting up processes and documenting those things and making sure that everyone is able to find out what is going on, that if you ever need to reference anything, everyone knows what's going on. If you need to make changes, there's records of that. And so documentation is a big deal here. Documentation comes in many forms as well. Documentation is simply recorded words about, an explanation of a thing. Hey, this application is located at this place. It is designed to do these things. It is maintained by these people. Here is a change log of when things happen. But documentation can also be technical documentation. It can be things that technical things that describe the application that have metadata about the application. There's all kinds of different forms of documentation, but they're all just tools to help you understand what in the world is going on, so that if anyone ever needs to hop in, they can do so. So that's all documentation is. That's all documenting tribal knowledge. It's very important. I'll be honest with you right now that nobody does this well. No one. Even if you think you do it well, you don't do it well. It is a difficult thing to do because you are taking something that you know and you are trying to write it for a theoretical person who doesn't have the same, the rest of the knowledge that you currently have. You're writing it from a viewpoint that has a bunch of extra things in there. Ooh, Melky. First off, that was a good timing. We were leaving off of the tribal knowledge conversation, and we're about to move over to the CI/CD management. But welcome everyone from Melky Dev's channel. Anyone who is new to Twitch here, and you see us raid people at the end of the channel, that's what's happening right now. Melky Dev is a part of the Only Devs team. I'm pretty sure you're part of Only Devs and Programmers, but he's a part of the stream team that I am a part of. Welcome. I appreciate the love and the support. Welcome everybody from Melky Dev's channel. Come on in. Come on in. We are on day 2 of our journey into DevOps and site reliability engineering, into software delivery, automation, and infrastructure. This course is called Pipelines, You're in part 2 of 16, and we're just getting started. So come on in, get comfortable. Today we're talking about roles and responsibilities. It's pretty chill night tonight. We're not super deep into the technical stuff yet. Thank you so much everyone who is following Revived Newt. Cineliples, I love the name, that's amazing. Ian Alex Hart, welcome. That noob, welcome. It's NOYC, it's Noik. Yeah, or it's no YC. I don't, welcome. Anon Virus or Vius, welcome to the channel as well. A couple other people have followed. I appreciate it. Appreciate the love, appreciate the support. But like I said, come on in, sit down. We're gonna have a lot of fun tonight. We're talking about roles and responsibilities. We're about to talk about money. And then we're gonna do a basic Git intro for now to kind of get us started. And then we'll get some dev environment stuff set up. So yeah. Dvorak. I might have to start using Dvorak since I'm not a good typist for QWERTY. But I appreciate that. I appreciate that, I'm starting to feel like my voice is an asset, so I do appreciate it. If no one documents well, how can that be improved? It's a great question. So I think the best opportunity for improving documentation is when someone has to use it. And whenever someone uses it and goes through and can't clearly understand all the pieces of it, or exactly immediately understand what all the information they need, you have to take it upon them to correct those things. You will get better at documentation as you go along. You'll understand some of the things that you should hit that people usually aren't thinking about. Everyone will get their own style of it, and that's the problem. The same way that we all learn differently, the same way some of us like to read, and some of us like to but some of us like to hear things, some of us like to see videos to learn things. Documentation works in a similar way. Documentation is almost always text, and it can be tough to convey all the things that you need to do through there. So yeah, just time to do. Honestly, if you just keep doing it, you'll get better at it. And as you come across documentation that it isn't amazing, make edits to it. Either request edits or make edits yourself to it. And eventually it'll become as good as it can become, to be honest. Someone should document how to document. I'm sure, I'm sure there are people out there who are good at it, but a lot of people are not good at it. And then on top of that, one of the biggest problems is that it's not so much that people aren't good at it. It is that it is hard to maintain. It is hard to keep up a good documentation practices when you're in the heat of building applications and you have deadlines and all those kinds of things. It gets tough to kind of keep those things up, and it's always the first thing that falls off the radar. So as you're going into to be a DevOps engineer, especially in your early days, document. This is going to be your best friend. You should start practicing this on your own right now. Start documenting things in a way that's not writing down every single thing, but is giving you enough information so you know how to reuse things, you know how to implement things, you know why decisions were made. It'll be helpful for you, and it can be super beneficial for people on your team if you're trying to figure out how to be valuable while you are learning. So cool. Revive Newt, dope. I appreciate that. Yes. Oh, that's a good one. Document like you're leaving in 2 weeks and have to turn things over. That's a good one. You never write better documentation than when you're about to leave, to be 100%. What's up, Ammonia Flows? It has been a while. It is good to see you. And whenever you need to fix whatever is wrong, then move on to the next burning dumpster. There's never a lot of time to Yes, 100%. Yeah, then you make changes to things. Applications evolve constantly, and it is hard to go back and do that. So, keep it on your mind. I'm not going to sit here and act like I'm the most amazing documentation expert here. I'm not. I'm going to be very honest with you throughout this entire course, but it is something that is important. I've seen, you will quickly see the need for good documentation, but it's a problem at just about everywhere. So just, make sure you're thinking about it. It is a responsibility of yours, whether you're doing DevOps, site reliability engineering, especially anything infrastructure related. Documentation is key. Unique ID, Happy New Year to you as well. All right, so the next thing is CI/CD management and automation. And again, like I said, this is a very generic list of primary roles. This is not the de facto list of primary roles. These are ones that I really wanted to throw in there to have conversations about. One of the biggest things in DevOps, where people feel like it's DevOps, is the implementation of CI/CD. We're going to dive heavily into CI/CD. This stands for continuous integration and continuous delivery. This is generally, when people are talking about pipelines and code pipelines, they're generally talking about this process of continuous integration and continuous delivery. But you, as a DevOps engineer, your primary role is usually to be the arbiter of these systems. Why? Because you are the person who's responsible for these development processes. Okay, you're there to make sure that there are processes and pipelines set up to be able to deliver code, efficiently and effectively. And usually that means setting up things through CI and CD. This means using tools. Remember, we looked at that tools chart. If you go back and you look at the list of things on the DevOps roadmap, which we can take a look at, we're talking about those tools such as Jenkins, a big one, Circle CI. We got Travis CI. We've got Bamboo. I think Bamboo is one of them. We've got GitHub Actions. There are a bunch of tools that enable this for us. These are CI/CD specific tooling. You don't have to use one of those tools. You can do, I've seen manual CI processes. But again, these are just, GitLab CI, 100%. I love GitLab. I'm working on a project in GitLab right now. To be honest, I use both GitLab and GitHub for different things. But this is usually, you're the arbiter of this. And like, this is a surprisingly big part of what companies feel like DevOps is. They're hiring you usually to be a big part of setting this up. You may be setting it up from scratch as new projects spin up, as new tools spin up. You might have to set up new pipelines pretty often, maybe, or you might be working somewhere with a pretty, a big application that's updated constantly, and you maybe set up once in the beginning and never have to touch it again. But you're usually the arbiter of that workflow in those processes. So you maintain it, you add to it, you help people understand it. And that's usually a big part of what you do. This third one probably should have been the very first one, but developer support. This is not developer support as in, hey, the developer needs help fixing this feature or figuring out what's going on. Excuse me. It is that you are, again, you're the arbiter of the development process. You really are the person who's looking for the efficiencies, building ways for people to, okay, let me finish this statement first. But you are building ways for people to deliver code faster. Okay. And your job is to find out what they need. The developer is in fact your customer. And that's how you should be thinking. Your job is to help deliver the code faster. And so developer support is getting things in place, understanding what the developers need, and making sure those things can happen. Now we got to find a way to repay Nika codes. First off, I'm going to send you a whisper because thank you. I don't even know how to properly thank you for gifting 100 subs. That is absolutely the most absurd thing that's ever happened here. I cannot tell you how much I appreciate that. First, to the community, please help me in giving a massive round of applause in thanks and appreciation for that. Everyone, I would say everyone who received a sub, but I feel like everyone received a sub just now, including myself, to my own channel. But I appreciate that. Please, I'm gonna send you a whisper. Please, you are absolutely entitled to a Mastermind Ultimate sticker pack. As we saw on the first day, you're also entitled to some sweet Mastermind socks. I will get those shipped out to you immediately because that is some love and support that I've never, you've got me taken aback right now, and I'm getting a bit emotional. And I really, really do appreciate that. And we're gonna make those subs worth it. We're gonna make some really cool things happen. So I do appreciate it. Also, now you made it so that I can at least buy my new baby coming up, not yet, at least a couple diapers. So I do appreciate that. Dang, you really, you stopped me in my tracks. I appreciate that. All right, let's see if we can keep going after that immense show of respect. Now we gotta get real now. This will be good because we're about to talk about money in a little bit as well. And it says my hype train is at level 5 and it's at 1,440%, which is pretty wild. I don't even know what that means, but it's pretty out of control. Thank you, Dorothy, so much for your gift of sub. Equal love and support. I appreciate it. Thank you so much. Oh man, CM, first off, welcome. First off, let me give a couple shout outs because I haven't given all the shout outs that I need to. One, Melky, thank you so much for the raid. Let me first give you one. Melky Dev does some great development stuff here on Twitch. Remember, I told you there's a lot of great people to follow here on Twitch if you're trying to learn, you're really trying to immerse yourself into all these things. So thank you very much for that. Also, let's Mr. Griffin, we rated Mr. CM Griffin the other night, who also does some great stuff here. Please go give him a follow. Does some great stuff as well. Also, a really chill stream to watch if you're trying to relax. I lurk in your stream a lot when I'm working. It's a pretty chill stream to live with. Revive Newt, thank you so much for the cheers and the bits and the love, everybody. I appreciate it. It's never going to get easier for me to accept you all's graciousness. But the way that I'll do my best to do it is, more courses, more access for people. You all really are enabling me to do this for a lot of people. We're starting to try to do some stuff for middle schoolers and high schoolers as well, specifically for them to give them kind of hands-on one-on-one. So I appreciate the love, really do. All right, how do I check if I'm a sub? I think the only way I would know to check is if you click on your little emojis button and you see that you have my emojis. They're literally pictures of my face. That's one way, maybe. I don't really know. Oh, actually, I think I can see. I think you guys have little markers by your name. I think that's what that means. And you don't have one, so I don't know if you are. But yes, thank you so much. And yeah, we did get rated by Melky Dev. So dope. All right, so on to the next one, process automation. This is why CI/CD is so great. Death Cheese, thank you so much for the Twitch Prime sub. Process automation. This is not just the automation of development processes. This is automating any process that makes sense for the business, that helps the team, the organization move faster and deliver software as fast as they want to. Okay, so this is why everyone talks about automation. This is why everyone is learning how to code, because you're looking for ways to create efficiencies in your workflow. I just tweeted the other day about finding an efficiency in my workflow. It can save companies massive amounts of money. It can save engineers massive amounts of time, massive amounts of energy. So automation is a good thing. It's a great thing, and it should be at the forefront of what you're trying to do. You're trying to take anything that happens over and over again and make sure that it is set up in a way that can happen automatically with the least amount of human interaction possible. And so process automation is a main role of a DevOps engineer. All right, so now we have infrastructure management. And this one's very interesting. I've gotten into some funny conversations with people because of what we're going to talk about next with SREs, but infrastructure management. You are managing the infrastructure that serves up the applications that are written. The software is the real star of the show, but for that software to reach the people, for that application to reach the people who need to use it, it's got to be operating on some type of platform, some type of infrastructure needs to be running this stuff. And it is up to you to manage those things. Not only manage them, you're generally creating these things. You're running them, you're maintaining them, and you're usually constantly adding to it or modifying it so that it can be the best that it can be to both deliver good performance or save money. All that's really, really important. Now, I'm gonna bring this up now so we can talk about it later. DevOps and SRE, tons of overlap, but your focus in DevOps is the software. It's the delivery of the software rather than the infrastructure. That's not your main goal. The infrastructure that you're focused on is the infrastructure that supports that software delivery. Now, a lot of the jobs will still have you be in control of the actual production software and making sure those systems are reliable. But it is possible for your job to stop at software delivery, okay? There are DevOps teams who don't touch production infrastructure. They help mirror, they may set it up, but they're not the ones who are responsible for maintaining it and making sure it's okay. They are, they're specifically doing the things that support the software delivery. But infrastructure, this is like your servers and your storage and all that other stuff, all the tangible web infrastructure that your stuff runs on is what we will be doing there. So cool. Oh, will you discuss how you save yourself 3 hours? Yeah, for sure. Let me finish this out. Let me talk about monitoring and collaborators real quick. But I'll talk about that immediately. It's dumb, but it helps. Performance assessment. Remember we looked at that infinity loop for DevOps where everything fed back into each other. We plan the stuff, we build the stuff, we deploy the stuff, we operate it, it's out there in the world, and then we monitor it. We make sure we understand what's going on with it so that we can get quick feedback. We take in that feedback and we use that feedback to make decisions about what to do next. And so performance assessment is really just a all-encompassing word for making sure that the applications that you're running, that you're responsible for, that you're helping build, are working in the way that they're intended or up to certain standards, and making sure everything's good to go, honestly. So there is a pillar of DevOps called observability. It's a big section of DevOps that includes monitoring. There's other pieces in there that allow you to be able to get enough information out to be able to make decisions based on that information. And that's what performance assessment is. And monitoring, use monitoring to help you make those performance assessments as well. And the last thing, your primary role is to be a collaborator. This is a huge one, but it is to understand what the developers need, what the company needs, what the business needs are, so that you can enact the right solutions. This is not a role where you are simply, or shouldn't be a role where you're simply taking orders on what to do. It's a collaborative, conversational role where you are doing your best to understand the needs, the direction, all that, so that you can understand how to best implement solutions for everyone. Because people will tell you to go implement things that they don't really need, or that won't really provide them any value. And so, everyone thinks they need something until you implement it and it doesn't work how they thought it was going to work. So it is a very collaborative thing. It is a very conversational thing. So make sure you are talking to people and understanding to the best of your abilities, all of the things surrounding your role that you can, so that you can help make the best decisions for what's coming in the future. I did not recommend the Google Sre Book yet. It is, I think it's, it is scheduled to be in the Google Classroom for sure. Recommend it, bring it up. Like I said, Google literally wrote the book on SRE. The role was born out of Google, but they actually wrote a book with O'Reilly on this. It's really good. It's pretty cool. But 100%, you should check it out. And I have a link for it. It's completely free. You can just kind of download it. So yeah, it's pretty dope. All right, so these are the primary roles of DevOps engineers. There are, like I said, many more that you might face, but these are the ones that I thought we should call out. Okay, the thing, the process automation that saved me so much time this week was, it was kind of automation. It was also a tool switch. So one of my problems, one of my time-consuming things was that after every stream, I would take it's recording right now, the same time that it's streaming. I would take that recording and I would trim off the 10 minutes where I start the stream, where there's a starting soon screen. And then I would have to re-render that video out after I trimmed it off. These are 3-hour streams sometimes, and these are 4K recordings. I record in 4K, stream in 1080, and that would sometimes take, it used to take maybe 2 hours to do, and then I got a 3090, and it would take less than 2 hours to do once I moved to 4K. But I found out that you don't need that I did not need to do that. I didn't need to do any of the I didn't need to re-render it. I looked for ways to do this before and I couldn't find it. Someone brought it up and I didn't understand what they were saying to me before, like a long time ago, but I switched to using FFmpeg, which is a command line utility for modifying videos. And I was able to write a little script it's watching my directory where this recording is, saved to. It automatically knows when the original file is an MKV file. It will automatically, when it closes, like MKV has to be closed, well, all of them have to be closed. Once it's closed, it'll see this as a complete file. The script will automatically pick up this file and it will look for, my starting music has a specific, it's not always the same amount of time, but there's a specific sound signature change that I was able to find somebody else who did a script that did this, and I was able to pull their little bit of code to be able to know when that happens, and it trims it from there to the very end of the video for me, no problem. And it only takes a few minutes because it doesn't need to re-render out. It just needs to copy to a new file. So now it takes like 2 minutes and I don't have to do anything at all, which is great because I used to have to open up Premiere Pro, find the spot, cut it, delete it, pick where I'm going to save it, render it out. I generally couldn't use my computer while it was rendering, so I'd have to go do something else or go use another computer. It was a lot. It was a whole lot for no reason. And so it really has saved me a bunch of time. So I'm pretty excited about it. Definitely pretty excited about it. And I'm sad I was able to put it into a little Python script, which I'll definitely share. I'll definitely share that to you, sure. Yeah, 100% tools working for you. And I just need to, this is a relatively new space for me. I'm like content creation. So plenty of people probably already knew that I didn't need to re-render out these videos, but I thought that I did. So yeah. Okay. Let's go on to the next one. Is there anywhere I can get this talk? You can read, I mean, it'll be available here and then on YouTube. If you hit !YouTube, it'll go up there. And you can do it. If you mean the slides, hit !slides and you can get these slides right now. And so I actually have a lot of blogs planned. It's not something that I have been doing, but you know, I'm working with a social media person and a marketing person. They're like, yeah, man, you gotta start putting out some posts, some blog posts and stuff. I was like, fine, I gotta be a writer, I guess. But I've had a good time doing that because I've been surprised at how much I like reading about people's specific experiences and specific things that they're doing. It's pretty interesting. Oh yeah, the recording's on YouTube. If you hit !YouTube, it'll go up in 24 hours. Sin City, nope, you haven't missed too much yet at all. All right, so now for primary roles for SRE. Now you'll see a little bit of overlap here, but this is a little bit different because again, you're focused a little more on the infrastructure and the reliability of that infrastructure. So building software to help operations and support teams. Now, you are part of basically the operations and support team, but remember the definition that we looked at for SRE, for site reliability engineering, was that this is a software methodology. Like, this is not an ops methodology. It's software first. And so you're actually building software. Like, very often you're building real applications. You are also building scripts and smaller efficiencies, but you're building applications for teams to use to help them out, to make things easier for everyone. So that is a very, very important part of it. And this is the part that usually catches people off guard. Not all the roles you're gonna be doing this, because like I said, people use the terms interchangeably for sysadmins who do a little automation, and some people really want DevOps engineers but put site reliability engineers, and vice versa for sure. So you're not always gonna have to build real software, but it is a thing at a lot of organizations that you are writing significant pieces of software. So that's a big deal. You usually have to know software pretty well. Fixing support escalation issues. So one of the biggest differences, one of the key differences for me that I like to highlight is that site reliability engineers usually operate a little more in the ops lifestyle, in that they're usually the ones responding to break fix incidents. They're usually the incident response teams. They're usually, when something goes down, they're doing larger scale monitoring on the systems, and they have to respond to these things. This goes along with optimizing on-call rotations and processes. Usually site reliability engineers are the people who are on call for production issues. Okay. You know, again, this is also generally a scale thing as well. Lots of servers, lots of big, like pretty big systems, but SREs normally focus on that process. All my friends who are SREs are on call, and I haven't been on call in at least 5 years, which has been love, to be 100% honest. Also, you should build your things in a way that they can't catastrophically die. Now, it's not always possible, but one day I'm going to share with you all throughout this process my beliefs on current architecture for greenfield projects, so that you don't have to worry about being on call. We'll talk about that. But documenting tribal knowledge is also here. This is a big deal here, a very big deal here as well. Just like it was in DevOps, we talked about what it is, but documentation is a big deal. And conducting post-incident reviews. This is a big one. If you did watch the talk from the woman who worked at Gremlin, which is a chaos engineering company. We'll talk about chaos engineering one day as well. But she talked about this, and this is post-incident reviews or post-mortems are a way to review incidents that happened in a way that's done blamelessly. So instead of assigning blame and trying to get someone in trouble for an issue that happened. An issue that happens is not a single person's problem. It is a problem of the organization. It is a systemic problem. We need to take some time to identify what the problem is, what the resolution was, how long it took us to fix it. Is this a permanent fix? Is this a fix that is feasible to live long term? Do we need to do anything else about it? And figure out how we can make sure things like this don't continue to happen into the future. This is a big thing that site reliability engineers do. There's some really great, and actually, now that I said that, I'm gonna go share some good ones with you. GitLab had a substantial outage where they did a live postmortem on YouTube. It was super impressive. They wrote an amazing blog post about it. I definitely want to share it so you can see what this is. It was really good to see, because I think it encourages other companies to really operate in this model, to say that, hey, if we allowed a single person, if one person was able to take down our production database, that is not a problem with the person who did it. That is an issue with our system that we need to work out, or issue with our processes that we need to work out. So I'll definitely share that with you, but that's a big one there. And then collaborators, same thing. These people need to collaborate as well. Notice the very first item in this list is that they build software to help operations and support teams. And that's I threw that in there because I was looking over some stuff and I saw that there. It's not just operations and support teams, but they are a helper of everyone, really. And usually the efficiencies and things that they're putting in place and the reliability that they need to achieve usually is at the cost of someone else's ability to move fast, or at the cost of their ability to use something that we're using. And so there's a lot of collaboration happening here as well to make sure toes are not getting stepped on, make sure that they are fulfilling their role in a way that is beneficial to the organization. So these are, like I said, primary roles of these. That's why I put primary there, because there are many other things that you might be asked to do, but there is a lot of overlap here. That other video in there about the differences between DevOps and SRE from Google is that you might have seen that it said SRE implements DevOps. And again, SRE has a lot, you may implement a lot of DevOps concepts to achieve your job, but remember what the end goal is. The end goal here is the systems, whereas DevOps, it is what's supposed to be the software and the delivery of the software. But also they are in the real world, they are very interchangeable at a lot of places, not everywhere, but at a lot of places. So just keep that in mind. All right, so that's the end of just this part. So real chill. Well, no, it's not. We need to go talk about money. We did it backwards. So we talk about money. So not the end of that part. I'll take a little water. Which class? Well, no, actually, that was the sensitivity. Let's see. Sell discount going on, so you can get the course for like 300. What's that for? Then how do you handle outages? Just wait for a third party to go back up. Well, actually, these are all replies to everything. Let's see. Let me see if I can catch up to the conversation. Our SRE is responsible for integrating multiple pieces of software, writing glue code where there isn't a seamless integration. That's a good one. That's a great one. I've seen that as well. Yeah, writing integrations. They really do. In my experience, I talked to some software engineer, to some site reliability engineers who don't write a lot of code. I've talked to a couple of them, but most of the ones that I know write a substantial amount of code. And that's why it was a pretty interesting thing to me. I really wanted to dive deeper into some more higher level SRE roles. The largest company I ever worked for was ZeniMax Media. They were the parent company of Bethesda. They're now purchased by Microsoft. Like I said, I worked on the Elder Scrolls Online launch. I worked on help setting up the infrastructure and stuff for that. And that was like the biggest, like scale wise of the infrastructure itself that I ever worked on. But I really wanted to work on a much bigger global system before my career was over. And I'm still interested in doing so, to be honest. I want to see kind of how that works. Like, I just don't understand how a company like Google works. And it maybe it's that they have so many people that no one's really dealing with it on a global scale. Everyone's dealing with their own individual pieces. But I don't know. I would love to see how site reliability engineering is done at like a massive scale. It's very intriguing to me, but I also don't want to be on call. I also don't like being the the maintainer of the system, even though my passion is infrastructure. I don't want to I don't want to be on call, man. I don't like responding to break fix, even though I'm good at it. A good mix of 50% coder, 50-50 coders and sysadmin skills. Yeah, and that's usually what people think DevOps is, and it's not. DevOps is actually generally is less coding than site reliability engineering. It's more configuration as code than actual software development in DevOps. That's a big difference as well. And I find that easier to approach. I think when we get to the parts where we're doing, infrastructure as code pieces and things like that, I think you all will start to see that it's not quite as intimidating as pure programming is. But yeah, it's all good. Microservices, loose coupling services, I'm all about, we have a day talking about, or a week talking about distributed systems and understanding microservices and how all these things work. I'm a huge fan of microservices. They have their downsides for sure. But I personally love them. And we can talk about why, but there are a lot of things that I would do nowadays if I'm responsible for building something right now. Almost 98% of greenfield projects, if you come to me and say, Aaron, you're the architect right now, how are you going to build this thing? I'm going to tell you, one, it's going to be serverless. Guaranteed, it's going to be serverless. That doesn't mean it's going to be easy to manage, but it's going to be serverless because, again, I don't want to be on call. I'd rather manage it than be on call. It's going to be serverless, or as serverless as possible. All the pieces that can be serverless will, in fact, be serverless. All of the pieces that can be static, I'll make them static. There's a lot of things you can do to make sure things are good. I'm a fan of, I talked about it many times, I'm a fan of build time configuration rather than runtime configuration. So I'll do everything beforehand. But I don't know. My goal is to not respond to any problems, for sure. Yeah, multi-AZ works for me too. I'll even go multi-region. I'll go multi-cloud if I need to, but I don't want to respond to anything at all. Definitely I don't want to. All right, so here we go. Let's talk about money really quick, because money is important. So this is the only slide for money. All right, and here's what I want to, so take a look at it. Note, I want you to understand that this is not fact here. These are estimated median ranges. Now, what goes into salary? Salary has a lot of things that go into it. Your locale. Locale is very, very important. Probably the most important thing. Your years of experience, the size of your company. All these things matter, okay? But I want to make sure that everyone talks about salary, or at least the conversation starts about salary, because it's one of the hardest things to I find for people to be the hardest thing to navigate when they're getting into the industry. And I want you to, if you're going to spend the time trying to learn these things, I want you to know what you can make. And yes, these are in US dollars. That is a great question. I should add that to these slides. Okay. These are in the United States. When I was looking through things, my own experience, all this, I've done I was doing some market research. These are a very wide range of estimated median salaries, and this is for all infrastructure fields. And so that's why these ranges are so wide. And they actually could have been wider, but I tried to close them up a little bit because it was all over the place. Now, the very first thing I have on here, I don't want you to be afraid. I just saw somebody saying they weren't making your entry level, and I make way less than that as a DevOps engineer. Again, this is he said way less. I don't know everyone's situation, but for an entry level role, netting you the title of DevOps engineer, whether it's junior DevOps engineer or whatever, or site reliability engineer, even in terms of cloud engineer stuff as well, the median entry level range for these things is around 60,000 US dollars. It's around 60,000. And again, where you live, all those things are taken into account. I actually threw out some of the lower numbers and some of the absolute highest numbers, because I found plenty of reports, people going to Silicon Valley directly out of college to be DevOps engineers and getting paid $150,000, $160,000. And I was like, dang, that's pretty good. Maybe I should go out there, but maybe I should have went out there when I was a beginner, because that sounds amazing. I don't know what I would have done with myself. Cost of living would have sucked, but it's around $60,000. Now, this is not to be confused with an entry-level tech role. All right, it's definitely not to be confused with an entry-level role in technology, okay? Remember, we talked about this. We talked about all the different skills that are needed to do some of these things. They come at a high price. And, I think 60K is actually at the low end for, a DevOps engineer or SRE, to be honest. And like I said, entry to entry mid-level goes to about 95K in most places across the United States. Yeah, there's definitely a margin above and below, but there's a general range there. Entry mid to mid senior is about 95 to 150. There's a lot of variation in there, tons of variation. I saw a massive amount of jobs in a massive amount of median incomes in different places, right in the 120 to 140 range. So there are a lot of mid-level roles that are in the upper end of this entry mid to mid senior, but they're usually around this area. Mid senior to above, it can really go to into however much experience you have. I've seen astronomical salaries in this field. I've seen salaries of $700,000 and $800,000. That is unlikely to happen. But salaries above 150 are very normal. Especially as a site reliability engineer. If you are on the coast, if you are in New York, if you are in the Bay Area, absolutely salaries in the 180s and up. So, depending on where you go, salaries can get astronomical, but those roles will demand a mastery of a lot of these skills, much more mastery than you can get here. I'm telling you right now. Okay, we're not getting political here, but you all see that normal people were able to just storm the Capitol. Okay, our government is in Washington, D.C. There are a number of government organizations. They all have tech sectors, and they need people like us. I'm telling you, you can be very average. You can have a little bit of skills, and you can make 140, 150 in the DC area as a mid-level engineer, working as a contractor for the government. If anyone from the government's watching right now and you are mad at me for saying that, 100% true. It's 150% true. You can be very average and make a substantial amount of money. Like that's good money because they have to charge. There's a couple different things. There's a thing called the GSA schedule. Which helps demand rates for work that is done for the government, and they go by market rates. And so companies can charge the government, absorbent amounts of money, because that's what the rest of the world is paying for these skills, and the government is kind of okay with mediocre work a lot of the times. And I'm saying that as someone who's worked with the government many times before. It's pretty crazy. But yeah, like these salaries are in the United States. I know a lot of people tuning in are not from the United States. I don't know about salaries in your area. Definitely hop on Glassdoor, definitely hop on Indeed, do a little research. But in the United States, these are absolutely attainable salaries. And now let's talk about what goes with these things. Entry to entry mid, like I said, you need to know a lot of the things on that roadmap. And I wouldn't say know well. I would say have a mastery of one of the things. Like, I think if you're a good systems admin, if you know Linux well, and you know how to like work with web servers and stuff, and you know a little bit of automation, you can walk into an entry mid role. I fully believe that if you know the cloud really well and you pick up one other thing, if you know cloud and containers, 100% you can walk right into those entry mid roles. I would say that an entry level engineer for DevOps and SRE probably has around 2 to 3 years of experience, to be honest. The entry mid, I think most of your mid-range engineers at the same time is going to be around, they'll probably have a little bit more experience, but I think that if you have about 2 years in an entry level role, in an entry or entry mid-level DevOps or SRE position, a real position that's really testing your infrastructure skills, your automation skills, I think if you spend 2 years doing that, you are now mid-level. I think you can jump up from I think you can jump up from 90,000 to 130,000 like this. I'm so serious, not at all exaggerating. You know, I'm in Baltimore. Baltimore is not the hottest market at all in the world, and people are making big jumps. I worked for a company called Fearless. I'm actually wearing the shirt right now. If you head over to fearless.tech, you can check them out. They hire a lot of DevOps engineers, but they had an open salary. They tried to work with an open salary for a little while. It's still pretty open. It's still pretty it's a transparent salary proposition. And generally, one of the interesting things that happened was, because the top tier was so high, we had a lot of advanced engineers in the company. We were really working on getting entry level engineers, and we decided to hire an entry level engineer. And it was someone who'd already been in the company. She was actually an intern at the company, and you know, we had to pay her market rate. Like you have to pay market rate for this. And for a DevOps engineer with about 2 years of work experience, but doing other things like what was she doing? She was doing QA, mostly QA work, a little bit of software work. I want to say they had to bring her in at like $85,000 or $90,000 because that's what the market calls for. And you know, I would have, let me tell you right now, let me tell you all this. If I was fresh out of school and I was making $85,000 or $90,000, you wouldn't know who I was. I would be standing in front of you right now with mink coats, maybe a grill or two. You know, I don't know. I might have tigers in my room right now. I would be, oh man, and that's why, you know, life works out how it does for everybody, because it would have been a wild time for me, because I thought I was balling when I was making 33,000. I was like, man, my first job, I was like, man, look, and I was getting paid every week, richest man in the world. But this is what the industry offers. What's funny about it is, what's not funny, what sucks about it is a little bit, I have seen these salaries cause people to fall into a little bit of imposter syndrome. You know, when you're getting paid a lot of money and you don't really feel like you're all that great, it can be problematic. You can be scared of losing your job. But the more and more you explore, like I told you in the beginning, nobody knows it all. For the most part, nobody's that good. For the most part, most people aren't that good. People need these skills. There aren't a lot of people who have these skills. I'm telling you, I've interviewed a ton of potential DevOps engineers. I've interviewed tons of software engineers, and yeah, there are a lot of people learning these things, like all of us. But there aren't a lot of people who are good at this at all. And I would actually say that most people we hired, most people that we ended up saying yes to, their interview was average or even less than average half the time, because this stuff's hard. You know, like all the things that were on that list, all the things that are on this roadmap.sh, if you walk into an interview, you may get asked a question about anything on this, and each of these little things has a ton of stuff inside of it. And so you might get asked about anything, and it's very hard to like walk into an interview and know all the things that they bring up to you. But they generally are going to ask you things to kind of spark up conversation, to have you be able to talk about the things that you do know. So we'll talk about how to interview and stuff like that. But yeah, it's it's a pretty wild game. The money is good for sure. American companies still hiring IT overseas for like 90% of their roles. Yeah, I mean, American companies are hiring overseas. So I don't see a lot of overseas hiring though for infrastructure roles. I see it a lot for development. I don't see it a lot for infrastructure roles at all. I want to say I've almost never seen it for any infrastructure roles. Do you keep your LinkedIn and resume up to date all the time? I do, personally. Not my resume, definitely not my resume. I keep my LinkedIn up to date. And I guess that's done with now. I guess both of those are done with now. You know, God willing, I never have to go back and work for anybody. But yeah, I mean, I keep mine up to date because it can be pretty important to do so. Now, let's see. My LinkedIn is my resume. I agree. I keep my LinkedIn around as my resume. Internships for DevOps roles. That's a great question, Eastside Boy. There aren't a lot of them. And when I say aren't a lot, there are almost none of them. But that is something that I'm advocating for right now. I'm really, this is something very specifically that I'm trying to make happen right now. And more so infrastructure, DevOps, SRE apprenticeships, because here's what's happening. Companies, these salaries are going to continue to go up because there are less and less people. It takes so long to learn these things, or to not that many people want to dive into all of this stuff. And so there aren't a lot of people. And so people are just poaching people from different companies. They're grabbing people to stay there for a year. Someone else grabs them, pays them more money. Salaries just go up. Companies are starting to realize this, and they're starting to invest in stuff like this, into ways to be able to help build more engineers. And I think one of the ways that they're going to have to do that specifically is through really focused apprenticeships and internship programs. And so as soon as I can get some information, as soon as I can work with some people who are willing to do it, I'm trying to set one up at Mastermind. I have an apprenticeship program right now for software engineers. I have 4 software engineers going through it right now. So I'm working on it. I'm doing my best. We'll get there eventually for sure. But let's see. Roadmap has an accessibility issue, and the first component inspected. Nobody knows accessibility. That is true. You can make a lot of money in the accessibility game. People do not know accessibility. 100%. What's up, Sully? How you doing? Still haven't switched back to Pop. So no, Sully, great question. So, Windows is fine. Here's the reason why we're using Windows, and probably using Windows permanently, because you can do this. And I showed everyone this before, simply because when I need to, I can do this. Study this. This is why. This is the number one reason why we're sticking with Windows. I've learned a lot of cool things about this Surface, and that's why. And so if I can figure out how to do it with Pop on here, I will. 100% will. Hey, you are on that list. You are 100% on the list. I'm not joking. If 2021 goes how it's planned, we got some plans. Yeah, I'm definitely gonna be giving you a call for sure. All right. So, man, just looking at this, there's so much stuff on here, and I hate that it has this much stuff. But then I did go into something like front end or back end, and there's also a lot of stuff here too. And it's man, this is why tech is overwhelming. And you forget, as someone who's been in the industry for a while, you do forget. And I encourage anyone who's on here right now, when people come to you asking for advice, and you're pointing them in the right direction, be cognizant of how crazy all of this looks. There's so many concepts. Now, they're not all particularly difficult. You don't need to know every single one super well at all, but it does take time to get into these things. So do your best to be cognizant of that, because it's easy to forget how much you've learned. Imagine if you learned, 5 things a week, 5 different concepts, even if they're simple concepts a week for, let's say, how many weeks are in a year, 5 different things, 5 times 52, you've learned 260 different concepts over the year. So it takes time. It takes time to do, and you're not going to get 5 concepts every week at all. So that's on the high end. So there's a lot of different things on here. So just be kind. All right. So money, that's what you can make in the United States. Don't be afraid to ask for it either. This is your early interviewing and negotiating tidbit. If you are being offered a position, it is because they like you the best, and they do not want to lose you. Everyone's afraid that you will ask for more money, and they will say, nope, you're greedy, I'm not hiring you. That is not how it works at all. If we decide, if we get to the end of this process, it's time consuming. No one really likes to do it. When you get to the end of that process, we've picked the person that we really want the most. And if you come back and say, hey, I want more money, we want to have you. So we will likely do our best to meet with you, to meet you at whatever level you want to be at. So ask for the money. If they can't do it, they can't do it. And they will let you know. They'll say, hey, can't give you more money. Maybe we can give you more days off, something like that. But companies will negotiate with you 99 99.9% of the time. I'm only throwing 99.9 in there because I don't want people, I don't want the one person who their company was, they were buttholes and they were like, well, bye. I'm sure it's happened before, but it won't happen. It really won't happen. I doubt it'll happen to you. So yeah, ask for $1 million. Ask for it. I mean, you know, you should be strategic about the way that you say it, but you know, I mean, so that they take you, I want them to take you seriously. Okay. So if you say 1 million, make sure you're saying it so that they know, hey man, I want as much as you will give me. All right. For sure. What did they ask you before? Like during recruiting stage? So burning, that is a great question. That's a phenomenal question. Oh, it's a good one. There are a couple different rules that people follow for this. There are two main ones that people follow. One is to never ever say, give a salary first. Never ever give them a number first, ever. That is one school of thought. Then they have to play the game with you and offer you, you know, they have to do their best to find out how to get you. If you go through everything and they like you, they have to essentially give you what they have to give you. Now, that's one school of thought. Works sometimes. There's another school of thought called anchoring. And anchoring is where you throw out your number first, but you throw it out high. Okay? You throw out your number and you throw it out high. And so you've now taken control of the negotiations. You've really essentially controlled the starting point. Yeah, and you control the starting point. Again, they are both tactics. I'm not here to tell you which one works better. My school of thought usually is it depends on who I'm talking to. When I work with recruiters, I always anchor. When I used to work with recruiters, I always anchor. If I talk directly to companies, I would not anchor. I would not give them a salary until they made an offer. So it's your choice. But yeah, Penguin Airlines, I really like that. Say you need more time to get more information about the role and stuff. So that's a really good one. That's a really good way to say it. If they're asking you, say, hey, I need to wait and hear more about the role. I need to understand the full scope of this to figure out, what makes sense for me and my family. So that's okay to say. That's not going to be a deal breaker for them, I promise you. And yeah, that'll work. All right. So like I said, we're going to talk more about later on in the course about interviewing, about salary negotiation. So this is just a little light conversation right now about it, having a little fun talking about it, but the money's good. I will tell you right now that was the hardest thing to walk away from when I decided to start my own company. It was like, man, like the money is phenomenal. We were able to working, doing all the things that me and my wife wanted to do. Also, we were paying for her school out of pocket, for her master's program out of pocket. Not a problem. Like it really does. Again, I talked about tech changing not only your life, but it can change your entire lineage. Like the opportunities that tech can open up for you, honestly have been amazing. I was super spoiled because I've been in tech my whole career and I didn't realize how much people were paying for health insurance because most of every one of my companies paid for it for me. So one, I just want to say that now that I'm no longer employed by by someone else's tech company, I feel the world's pain. Oh man, I didn't know how much health insurance was. My brother was telling me that he was paying, hundreds of dollars per paycheck for health insurance for him and his family. And I was like, oh my gosh, that is absolutely absurd because I'm paying literal cents. I was paying like 80 cents for like really good health care. So, there are other perks besides salary. And make sure you're incorporating that into your pack. We'll talk about that too, but there are other perks. Pure cash isn't the only good thing that can come out of this. How much efforts in regards to time and dedication does someone need who only has surface experience with technology to become good and competitive? That's a phenomenal question. And I'm not going to give you, so I am going to preface this with the answer that everyone will give you is that it depends on the person. That's true. But here's what I would say. That surface level knowledge, I think the amount of time and dedication it's going to need is going to be, if you want to be a DevOps engineer or site reliability engineer, it's going to be how long it takes for you to get up to speed on one of two things, because this is what I see people are hiring for. You either need to get up to speed quickly on the cloud, specifically AWS or Azure. I'm sorry, I'm not giving any love to Google Cloud Platform right now. Or you need to understand systems very well. And that's really like that's something that you need to understand a lot. But you need to understand systems. So you need to pick up Linux and learn how, how a machine, how a system is used to serve information. That's really, really important. Okay. And so you really need to get really good at one skill to be competitive, to be able to talk about these things with some confidence. Time wise, it's tough. I mean, if I'm being 100% honest with you, I think you need, if you're putting in 6 hours per week, and you have guidance, I think you need 8 months. I think you need 6 to 8 months to be competitive in a DevOps or SRE role at the minimum. There are just so many concepts here, and I think that if you got hired before that in a DevOps or SRE role, you would be uncomfortable, and I think it would ultimately hurt you. Now, let me expand upon that by saying that everything that you learn here, everything that you're learning in pursuit of DevOps and SRE, there's a job for that in the tech industry. And all of those jobs, all of those roles, the experience that you get in them, absolutely perfect. Like it is acceptable as experience to get into DevOps or SRE roles, infrastructure roles. Okay. So if you want to become a cloud administrator, a cloud systems administrator, a cloud engineer, I think you can do it in months, like a couple of months, like 2 to 3 months, if you really want to. If you go get a certification, really pick up a skill, really pick up a cloud really well. I think you can honestly move into one in 2 to 3 months. No problem. If you want to go the systems administration route, I'm telling you, spend a little time learning Linux, you can get a systems administrator role. After that first job, it's pretty easy to move into whatever you want to do. People really just want to see that you have some experience. After you get that first role, it's pretty easy to move into something like this. I would not recommend a DevOps engineering role or site reliability engineering role as your very first role in the industry, to be 100% honest with you. It will make you uncomfortable, very uncomfortable for sure. But yeah, I mean, I know it's a roundabout answer. I know there's a lot of different pieces in there, but I really want to be honest about that. I do have something for you all coming a little bit later about the specific paths that you can kind of go into to help you move into a DevOps role easier, but like where you can get into the industry and start picking up some of this stuff. Knowing why systems interact with each other is key. That is, once you know the whys, once you understand the whys, all of it falls into place. And it's really hard to know the whys up front. I'm going to try to explain a lot of it, but yeah. Any tips for someone in desktop support role being stuck in help desk? My tip for you is that you only think you're stuck in help desk. You are doing exactly the right thing. Help desk experience on your resume works for all of these roles. You are more qualified now than everyone else who's just starting out for a step up in roles. I think that if you are doing desktop support, I think systems administration is generally the next move for you, or to go work in a NOC, in a network operations center, I think is a good path, an easy path, where they will take your help desk support experience as good experience and useful experience for those roles. I think help desk is a phenomenal place to start. I started in help desk. I get that question a lot, and I would say that the problem when people are usually stuck in help desk is that they have not yet been exposed to the concepts that we're learning here. And now that you're going to be exposed to these concepts, it's going to make it much easier for you to move out of help desk for sure. 100%. Now you can get stuck in help desk. Try not to. It's a terrible place to be, but I'm telling you, if you're in help desk now, you got a good resume already. I promise you have a good resume already. No matter what you're doing in help desk, it works. All right. We could talk more about that a little bit later. What I do want to do is get into a little bit of Git. I was going to push this off from today, but let's go over it really quick. We will re-go over this but I do want to go over it now to get you to see it so that we don't have to spend a ton of time with it next week. Why? Because you're going to learn Linux in 1 week. You are going to learn how to become a Linux command line expert and manage Linux systems in a single week. I do not want to take any of that time away from you by having to do any Git stuff. So I want to do it right now to get you ready. Do not sweat it if you don't understand what we're doing with Git tonight. This is only so that you can push your code up to GitHub. We will dive more into Git when we get into the coding section. There's a whole week of cozy coding. We'll dive into Git some more. Git is very important, and you're going to learn a little bit about it right now. What I do want you to learn, we are going to do some hands-on stuff with Git. You don't have to participate that if you don't want to, but you know, if you're able to, do it. But what I want you to focus on about Git is how it works conceptually. Do not worry about the specific commands to actually do stuff. I want you to understand Git as a concept. That is the most important piece. It makes it much easier to use when you get a little bit further along. So there are Git slides here. This is from our tracks course that we do run a Git specific course. It's a 4-part series. And I will share these slides with you really quick, just so you have it. Didn't feel the need to copy these into the other one. No, D-Flare, you do not need to know data structures at all. You don't need to know data structures just at all, to be honest. Great question, me too. When is the stream on Postfix or DevCot? You know what? Now that you said that, let me go to my calendar really quick. You know when it'll be? Y'all are gonna hate this. Whoa, what is this? Oh, Bing is so bad. Bing is the worst. You know when it'll be? It will now be, this is on this Saturday's office hours. Our first build series is Saturday the 16th. That is when it'll be. We are gonna build our own, postfix XM server. Now that you said that, that is going to be our very first build series thing. So if you want to come learn how to build and run your own mail server, your own email server, come on through, because Me Too just gave us our very first build series. Now we have to do it. We definitely have to do it now. Okay. That is what it'll be. I got it. I appreciate that, actually, because I have a bunch of different things put together. That is not one that I have put together, but I will be doing that now. I like that. That's a good one. I like that a lot. All right. So there's a Git cheat sheet here from GitHub. Hold on to it, bookmark it. We're going to learn about what Git is, right? Meow. What's the agenda for this Saturday's office hours? Oh, so the office hours agenda is, excuse me, that was gross. The office hours agenda is, there's really no agenda. I may go, we may recap some of the things, but it's just a time for people to come ask questions. Come on through. I will, like I said, I might dive deeper into a few things that we've done. But I won't teach anything new at all. During that time, it is really a time to ask questions. You can come ask the same questions you're having now. If you wanted to have more of a conversation about salary or anything, it is really just open time to really go through and focus on people's questions. So again, optional. You don't have to attend at all, but I wanted to create space for people to come along and come through and do that. Yeah, topics for security for spam bots. Yeah, 100% for sure. How to run your own mail server? Don't. That is what that class will end with. That build series that day will end with don't run your own mail server, but at least you'll know how to do it. I've managed mail servers before. It is the most miserable job on the planet. Don't do it ever. I mean that. All right. So here are today's topics for Git. Okay. Today we're gonna learn about what version control is. We're gonna learn what Git is, learn some Git terminology. We won't spend too much time on the terminology piece of it. Intro to Git hosting and GitHub, creating our first repo, and basic Git workflow. Okay. Yep, I can share the cheat sheet if you want to take a look at it. We'll get here shortly. Now, I was gonna preface this but I think I have this in the slides. So let's just talk about it real quick. What is version control? So Git is a version control software, but what is version control? Version control systems are a category of software tools that help a software team manage changes to source code over time. Now, any of you who have not were not in the decoded class and may not know what source code is. Source code is the human readable code that you write. So whenever people talk about coding and writing software, when people are typing on a computer, they are writing source code. It is the human readable code that you and me are writing, okay? And what version control does is it helps a software team manage changes that happen to code over time. All right, so the same way that in Google Docs or in Microsoft Office, when someone makes changes to a doc, it says, hey, this was last edited a little while ago, and you can revert back to different versions and stuff. Version control works the same way, but for code, and it's a little more dynamic than that. Version control software keeps track of every modification to the code in a special kind of database. So every time code is changed, every modification that happens, it saves it into a special kind of database. If a mistake is made, developers can turn back the clock and compare earlier versions of the code to help fix the mistake while minimizing disruptions to all team members. So it's simply a way to keep track of everything that happened to the history of a piece of code, so that if you need to mitigate any issues or turn back the clock to an older version or something like that, you can in fact do that. Okay, that's all version control is. It controls different versions of software. So that first line is pretty important. It keeps track of every software modification and a special kind of database. That's usually pretty helpful. People use version control systems. We just version control software. We write down our own source code. Yeah, if you want to write it down on paper and pencil, that works too. It works. Saving the final draft of a file. That's perfect. Now, this is really good because this is going to help us talk about why it's so important. All right, so people brought up all those concepts of like, hey, if you didn't use a piece of software like this, how would you write code? You would write all your code in a file. So code is just files, just like a document, just like a Microsoft Word document, just a file, nothing special. And you save it. Okay, you write your code, you save it. You make changes to it. You might save another file. You might save version 2 or something like that. And maybe version 3. Cool. You could do that yourself if you wanted to. You can save multiple versions, whatever, but there's no system there to make sure things are good, to compare things. It would be problematic. When you're ready to do the final draft, you might append final draft to it. Great, you could do that. Sounds like a bad idea to me. So if that's version control, if version control is designed to do those things, what in the world is Git? And why does everyone keep talking about Git? Purple Ultralisk, welcome to the channel. Thank you so much for the Twitch Prime sub. I appreciate it so much. So Purple has a special place in my heart. So Purple Ultralisk, welcome. But what is Git? Git is a lot of words here that we're going to break down. Git is a distributed version control system for tracking changes in source code during software development. Okay, so this is a tool. Git is a tool, and it's used during the software development process. Okay, when developers are creating software, it is used during that process. It's designed for coordinating work among programmers, but it can be used to track changes in any set of files. Its goals include speed, data integrity, and support for distributed non-linear workflows. A lot of words there. All this is telling us is that, and let's see if this opens up. Let's open up the whiteboard here. We're getting fancy out here. Let's create a new whiteboard. All it's saying is, one, it said distributed. What does distributed mean? Distributed means that these computers, let's do this, are in different places. So maybe this is Johnny's computer over here that was supposed to turn into a real square, but you have to draw a real square. Nope. And maybe this is Sarah's computer over here at her house. And maybe this is Tim's computer over here at his house. And they're all around the world. This is the world right here. Ignore, this is Florida. There we go. All right, the world, everybody. Amazing. And different people are all around the world at their computers doing work. Distributed means that they're in different places. Decentralized, I like that. Yes, that's what it is. It's decentralized. There's no central point for all of these things. It's decentralized. All right, so these are all, let's mark it. I don't know the best way to spell Sarah. Let's say this is Tim. And what is this? Johnny. I don't know how to spell Johnny. Whatever. Good. I'm not a good speller, to be honest with you. That's what autocorrect is for. And these are all their computers around the world. All right. Now, imagine we are building a piece of software, okay? We're all editing this doc right here. Now, this is a thing that happens. If this was a Google Doc or Microsoft Word doc, we could all be in this file at the exact same time. We could all be there at the exact same time, and we could be doing work together. We can see everyone's cursor. We could overwrite people's stuff. Great. That all works. Now, the problem is with code, this doesn't work the same way, or it would be pretty problematic because code is generally not done in one file. That's the first problem. It's generally not done in one file, and it has a reliance on the other files. Things like Word documents, you can edit each of those documents individually and it has no effect on the other ones. Code will have a runtime effect on all of these things. So yes, live share coding, it's a thing. We can actually do it. I'll actually have some of you hop onto my VS Code one day and we can do some live share coding together. But this is problematic. It's problematic for a number of reasons. People work on different time zones. People do a bunch of different things. We want to be able to work on these things completely separately at different times, okay? So how do you do that? How do you make it so that everyone can work on this same document? How does everyone work on this document right here without having to be in the document at the same time, okay? How does that work? And Git is what allows us to do that. So, one, all the stuff that we read, there is no central version of each code base, version of a code base. Each user has a working copy and the full change history of the code base. Okay, so that's the first way that we do it. There's no one place. So when we're talking about operating on Google Docs, there's a single Google Doc that exists inside of someone's drive, and everyone is modifying that one centralized version. This is decentralized. There's no central version of it. Everybody has a copy of the full history of a code base, and they all have it locally to their own computers. Tracks changes to code base and exchanges patches when a code base needs to be synchronized. So you might say, hey, if all these people, actually, I don't know how to use, there we go. If all these people have their own separate copy, Sarah's copy is different from Tim's copy, is different from Johnny's copy. They all have different copies, but each of those copies has the full history. How do you synchronize those things? When people make changes, how do you synchronize? Well, what happens is, let's see, can I just move over? What happens is, let's say Tim, this is Tim. Tim makes a change to the code. So let's say this right here is Tim's change. And he had a little code right there. All right. This was the original code base up here. So this is another box. Come on, square it up for me. Let's write over here, original code. Okay. And maybe the original code was just this. Okay. So all Tim has added is this piece right here. Okay. He hasn't added anything else. But when he adds the little red circle to the code has changed now. So Tim's change is the newest version of the file. Okay. So what happens now is using Git, Git makes a patch. So basically it makes this little delta file. And so triangles are for deltas. And the delta has basically, it basically tells the code base how to get from the original code, to the new code. Okay. So it makes a little patch file. And this is a patch file. All right. And then once it makes that patch file to let everyone know, to let everyone's code base know how to get from the original version to this version, then it gets distributed back to Tim and out to Sarah, kind of. This is what we're gonna go with for now. It gets sent out to them. They're able to retrieve this patch information. And because this patch information has how to get from the first stage to the second stage, it will do that for them in their own code base, okay? And so you basically pass around these patches to be able to update your code base and keep everything synchronized and up to date. Because of the way these patches work, they can come out of order. They can come, kind of out of order. They can come in different places. So there's a number of ways to work with it so that you can get things up to date. So it's pretty confusing at first, to be 100% honest, but it's easier to see once we start practicing it. But all you need to know about it is it allows Git or version control software. They track changes to code, and then they make little patches and exchange them when anyone needs to synchronize the code that they have. All right. So we're gonna see that in action in a few. But more about Git. It was created in 2005. It was created by Linus Torvalds, who is also the creator of the Linux kernel. And it was created for the development of the Linux kernel. Git might be, it's arguably, I think it is, well, second most, but it is probably the most influential piece of software ever to be introduced to the tech industry. Okay, yeah, it's probably the single most important piece of software in the tech industry. It is that important, and it is very in demand. You need to know. It is something that you need to know, especially when in this new world of doing infrastructure and managing infrastructure using software and through code. You need to know Git. You need to know how to manage your code files. Okay. What does the delay in patch distribution look like? So, patch distribution, I'm waiting until we get to a second part. Patch distribution it happens, it happens manually. Okay, so patches are only distributed when the developer when a developer needs them to be distributed. So a developer has to grab the patches, essentially. So we'll talk about that. Yeah, perfect. You said it perfectly, me too. Exactly. So yeah. All right. So this is where Git repositories come in place, and this is actually where we're going to talk about Git hosted repositories in a second. But it's all going to come together. There's still a few things that need to be filled in for you. We're filling them in. Just keep moving along, and then we'll break it all down and put it all back together. All right, so Git repositories. What is a Git repository? Repository is a word that you need to know. Our code needs a home. Git repositories store metadata for a set of files and or directories. Metadata is just a little bit of data that a little bit of informational data about something. It stores the set of files as well as a history of changes made to that file. So the repository is the landing place. It is the holding place of the history of a code base. Okay, a code base and its history are a Git repository. So the actual files that make up your code base and its history are the Git repository. Okay, it's just the holding place for it. Think of it like a folder, right now. Just for right now. Think about it like a folder. Okay? But if it's on my computer, how can others get it? If everyone's computer has a separate but complete history of the code base, if it's on my own computer and it's on Tim's computer and it's on Sarah's computer, how do I get it? And the way that we get it, you don't actually need one of these. Well, you do, but I don't want to get too deep in that either. War of the repository host. This is where hosted repositories come into play. This part is confusing for a lot of people because the very first thing we told you about Git is that it is distributed and decentralized. When you introduce a repository hosting platform like GitHub or GitLab or Bitbucket, it feels like Git is now a centralized thing. It feels like that, but that's not true. But all a hosted repository is a centralized place for everyone to go as the source of truth for code. Okay, a repository host can be on your own computer. A repository is the code base that's on your computer. you can have one on your computer. But these hosted repositories are companies who will hold your code for you. And they provide a number of services. They provide a number of tools that make it easy for many people to collaborate much easier. Okay, the three biggest ones right here are GitHub is the biggest by a substantial margin. It was acquired by Microsoft maybe 2 years ago, maybe. I don't know if it was even that long ago. But by far the biggest one, largest market share. You get unlimited free public and private repositories. So as many code bases as you want. You can make as many code bases as you want. But for private repositories that are free, you only are able to have 3 different people working on them, contributing to them. So only 3 people can push code to there before you have to start paying for it. All right, so unlimited free repositories, 3, you can only have 3 people contribute to a private repository. GitLab is not just a repository host. We're gonna go check out these sites in a second. But it's more than just source code control management. It is a full DevOps platform. Okay, GitLab has everything. It has a repository hosting for your code. It's got CI/CD. It's got monitoring. It's got everything. It's got a full pipeline built inside of it, and it's pretty cool. And it used to be a lot smaller, but when Microsoft purchased GitHub, a lot of people did make the move over to GitLab. And yeah, it's a great tool. I use both of them. I would check it out if I were you. It has some cool things in there like project planning, CI/CD, monitoring, metrics. It has unlimited public and private repositories. It's okay if you don't know what any of that means yet. We're gonna fill that in. Bitbucket is another one. It's an Atlassian product. If you don't know who Atlassian is, you will learn who Atlassian is, and you will hate them, as everyone learns to hate them, to be honest. This is not to say that they make bad products, but they will give you a reason to hate them. One of their most popular products that you may know about is Jira. A lot of people use it for project management and structuring projects and managing projects. They have Confluence. They have a whole suite of products. If you use Trello, they own Atlassian as well. I mean, Atlassian owns them as well. So Bitbucket is another one. I don't know much about Bitbucket, to be 100% honest with you. I've used it before. I've used a self-hosted one for a company that I was working for, but it's got a built-in continuous integration platform, and it also has unlimited public and private repositories. Yep, you see that? You see all this Jira hate? I'm telling you, you will experience the Jira hate. It sucks because everyone hates Jira, but Jira is the best. And I know it sounds weird. Everyone hates it, but there's really not a better option, to be 100% honest. So, it's pretty interesting. But these places, again, all these places they are a central place for you to host your code. Because, your computer's not always on, your computer's not always available. So if you're working on a project with somebody, if you're hosting the repository on your computer, how can Tim or Sarah go get their updates if you are out at dinner eating, or if you don't have good internet connection or something? There are a lot of caveats to why that's a problem. So these repositories end up becoming one of the people, and really the main place. It becomes the main place that has the home for your code, that contains the entire truth of the repository. And this can be switched up at any given time. So yeah, that's all it is. And this is the most important thing of everything we talk about tonight. Git is very important. You got to know what it is one day, but this is the most important thing. Git is not equal to GitHub or GitLab or Bitbucket, okay? A lot of people get this confused. Git is the technology. Git is the source control or version control technology that allows you to track the changes to code. Git is the technology. GitHub and GitLab and Bitbucket, all they are websites that allow you to put your code, using Git, allow you to put your code on there. They just house your code. It's just a place for your code to live. That's it. They give you some cool tools and stuff, but they are different. These are platforms for your Git code, for your code that is managed via Git. Git is the technology. So make sure you got that. All right. Git's the technology. GitHub, GitLab, Bitbucket. These are platforms for your code to be pushed to. All right. It's pretty easy to install. It's probably available. If you're on a Mac, it's probably installed. You don't need to install this now. I'm probably gonna, you don't need to install it now. If it's not installed, I'm just gonna show you some basic Git commands. We're gonna talk about the most basic of Git workflows, and we're gonna talk about some Git terminology real quick. I'm sure that you can install Git with Git, but that would be weird. I'm sure that you could if you could run Git before installing Git. Like if you had a Git executable that wasn't installed per se, like it was just a, all together binary, maybe that will work. But yeah. All right, so this is gonna make much more sense. I really wanna get to this part. I wanna go through terminology, and then I want to go through a Git workflow, because I think it'll make so much more sense to you when you see it in action, okay? It'll make a lot more sense when you see it in action. Gonna install Git on my toaster, you should. Go ahead and pull all those changes to the toast, to your blueberry bagel, after you put strawberry cream cheese on it. That sounds like a thing, 2 fruits. That makes sense. You get double serving of fruit. I don't know if the taste will clash, but it sounds like it might be okay. You develop your own Git tool to download Git. That makes sense too. You can do that too. All right, here we go. So let's talk about some Git terminology. There's a lot in here. We're not talking about all these. We're skipping most of these. Only ones we're talking about is we're gonna go backwards. Okay. Here we go. Let's start at GitHub. Okay, so GitHub is a site. It is github.com. And in fact, I'm gonna log in really quick. And here we go, conduit infrastructure. This is something we were working on before, in pipelines too. All right, so we got some code in here. This, what you're looking at, this conduit infrastructure, this is a repository, and I can share this link for you later, or you can go find me on GitHub. But this is code. This is code, and the entire history of this code is held here. And I can show you that whole history by seeing these 21 commits. This is the entire history of this code base right here, all right here. If I click on here, I can actually see the changes that happened every single time a commit was made. Now, you don't know what a commit is yet, but this is a code repository. This is what a code repository looks like, okay? Just a holding place for your code. Thank you so much, DMAC, for the Twitch Prime sub. It's good to have you. Really good to have you. All right, so now that you know that what a repository might look like, in GitHub is the home of this repository. So this is a version of the code in its entire history. How do I get this code and get that entire history? The way that I do that is through the Git terminology called, let's go back to where was it? Tracks is through pulling. So pull is the first one I want you to know about. Actually, let's do fetch. The way that you get that code is, nope. I'm not gonna give you fetch right now. It's pulling. All right, don't worry about what it says here. The way that you get new code is to pull new code. You are pulling code down from GitHub. I know someone's gonna be like, oh, well, no, it's a fetch and merge. Yes, it's a fetch and merge. We don't need to go there yet. We're not going this deep into Git yet. We'll get there later. Yes, cloning, you're right, cloning first. Do I have cloning in here? Interesting, I don't have cloning in here. So yes, cloning first. That's good. So actually the first thing that you would do is clone it, okay? So you do need to get a copy. You need to get a fresh copy of the code and its full history, okay? The files and everything. So the first thing you would need to do is clone it and git clone. I should add that to these slides. That's a good one. And so I'll do that right now, actually. I'll do that right here locally on my computer, so you can see what that looks like. Let's see, I told you this new build. I do have WSL2 installed on here. Is Git installed? Yeah, all right, cool. So I do have Git installed. Let me make this a little bit bigger for you. All right, let's do a little bit of stuff now. So I'm gonna make a directory really quick, and I'm gonna call this directory pipelines. I know I'm using all caps. I'm sorry, it's a thing that I do for directories. I'm sorry. It annoys a lot of people. It's what I do, just leave me alone, okay? All right, so the very first thing you do, I do like that, is clone. So first off, any command in Linux, which we're gonna learn how to use Linux next week, but you can type it in and it'll generally give you some use cases on how to use it. This documentation is hard to read if you've never seen it before. You might be looking at this like, oh my gosh, this is the worst thing I've ever seen in my life. I'm already overwhelmed. That's fine. I was very overwhelmed with technical documentation, especially from the CLI for a long time. Don't sweat it. But one of the things you can do is what are we doing first? We're cloning first. Clone a repository into a new directory, okay? So you don't even know how to do this, but just understanding that cloning pulls all the files and its full history from this site. So there's a little green button here, and you can grab the little URL here for it. You just copy it, and all you got to do to clone it on your computer is do a git clone and paste it in there. All right, and so now if I take a look at what I have a whole new folder on my computer now, and it consists of everything that's in this repository. So it's the name of the repository is the name of the folder. And if I go into it, you can see I have this .github folder and I have Terraform, this Terraform folder. And if let's actually put these side by side, you can see here that in this repository, oh, you can't actually see because, oh yeah, you have Terraform here. And so if I click on Terraform, and if I go into Terraform, you can see that you can't see. You can see that they mirror each other. I have main.tf, master.tf vars, main.tf over here, master.tf vars. Same files, the exact same files. If we open up main.tf, it's code there. And if we, don't have Vim installed on here. And we can see that the exact same code is on the left as on the right. So I've taken all this code and brought it down to my computer. I can even show you that I also have the history of this. Whoops, I didn't even do that. I'm going to do git log. I also have the full history. So if I go back up here to history, you can see that I have, let's see, it might be change production. What is this? Is this not everything? Oh, newer. Oh, this is the actual file. Hold on, let me go back to the whole directory. All right, here we go. This is better. You can see that it says change production EC2 instance size so that we don't end up poor. That same thing is listed right here. That was the last thing that we did. And before that, we did staging number 1. And before that, we did rename actions workflow and added Terraform workspace switch. So each of these different things are different changes in the code base. They're different. This is where patches were created and exchanged. So every time I made a change and I saved it, this happened. These are called commits. Okay, this is a very important term. These are called commits, or a commit. It is a single point in Git history, okay? So if I'm working on some code and I make some changes, let's say I add my name, I can save the file. That does not save it to the Git history, okay? Saving a file does not change the history of the code base yet. Why not? Because you wouldn't want every time do you know how many times you're going to change your code to get it right? You're going to write a lot of code and change things around, move things around. You have to manually create these point in time saves of code. You have to create these points in history. So when you get your code into a good place and you say, all right, I've done what I'm supposed to do, or I'm in a good spot and I would like to share this code out, or I would like to save this place in case I need to go back to it or something, let me go ahead and create a commit. Okay, so a commit is a point in time version of the code base. It creates a point in the history of Git, and I will show you that right now. So right now we know clone, which is going to copy a repository and all of its history and bring it down to your computer. And then we know about committing, okay? A commit is a point in time. So I'm gonna go ahead and I'm gonna make some changes to this code really quick, which I shouldn't do, but I'm gonna do it anyway. All right, so what I'm gonna do is I'm gonna say, let's go ahead and make a change to variables.tf. And this is some Terraform stuff. You'll learn Terraform later. This is just a variables file. So let's say, let me just copy this. And let's say I made a new variable called, called new variable, okay? All right, so that was my job. My job was to make a new variable. You know, maybe I had a ticket at work and it said, go ahead and create this new variable called new variable. That's all I did to it. This is a dumb code change, but it is a code change. All the code change is a change to text files. That's all it is. All right, so Git works off of a special kind of database. So check this out. This is not something you need to remember right now, but if I do git diff, it knows that I have changed something. It says, hey, this thing wasn't here before, and now it is here. It lets me know what file it was in, and it lets me know something has changed. How does it know this? It's because it has that database. That database has the way that the code exists, and now when I save the file, it knows something has changed. Now, nothing in Git has changed at all. Nothing in Git has changed. Exactly. This is the delta between what was there before and what is here now. Okay. If I was to remove something, it would also show minuses. They would be red and they would show minuses. Okay. So I ran git diff to see that. It's just running a difference between the old and the new. Okay. Now, if I want to say, all right, cool, I'm ready to save this thing. I did what I'm supposed to do. I'm ready to save this thing. We're moving into the Git workflow now. So the very first part of the Git workflow, I guess, is to clone. Okay. So git clone is the very first part. Make some changes to your code like I just did. The next thing I want you to remember, so after you clone everything, the next thing you want to do is this starts the real workflow. Clone is something that happens one time. Clone happens once. Now we start the normal Git workflow. The normal workflow is make some changes to your code. Then commit it, save it, say, hey, I completed this. Now it's time to make a point in time change for this code. And the way we do that is with the git commit command. Git commit. You have to give it a message. You have to tell it like what you're committing and why. You usually want to make this pretty descriptive. So I might say git commit added new variable to Terraform. All right, might say something like that. You want to make it descriptive because this is going to be an identifying factor for where you can go back to. Okay, so I do that. Okay, let me do this first. This is some extra setup. Don't worry about this part right now. We'll go over this later. It's going to tell you to do this. There's some basic setup that needs to happen with Git. This is a new installation, so you can copy these lines, and I'm gonna put my email in here, which you all already have, or I've shown a million times. So feel free to email me. And all this is doing is so that Git knows where to send things. It will. Don't sweat it. Like I said, don't sweat this part too much. We don't want to dive too deep in there. What's up, Strawn J? Welcome to the channel. Good to have you. What's up, HS Timmer or Timer or Steimer? H Steimer? Let's try that one out. Welcome. Also, Beta B Nix. I tried that too. All right, and so I set that up. So let's forget that. And let's go ahead and do our commit. Okay, that didn't work. It gave us a little red thing. Okay, change is not staged. So that's not all we have to do. We do need to change our point in time, but remember, there are a lot of files that can be in a directory. Right now we have a few. We don't have a ton, but there are a lot of files. What if you were modifying some and maybe you're modifying 3 different files at the same time, or like you've been modifying 3 different files over the course of a day or something, but one file is right, but the other ones aren't. You don't want to push up all those changes. So it is not going to automatically pull all the code. You tell it, you can explicitly tell it which files you want that you wanted to track the changes for. And so the way that we do that is we do a git add, and we add the name of the file that we want it to start tracking. All right. And a good way to see what's going on is we can type a git status, and you're looking for green. So here's our workflow so far. Clone first. All right, that happens one time. Clone it. Now the real Git workflow, the repeatable Git workflow starts. Make changes to your code. All right, when you're ready to save that stuff, you need to add what files you want to you want to make patches for. When you're ready to make a point in time change, you add the files that you need. So save, git add. Now you can do your commit. So once you tell it what you want to add to the commit, now you commit it. Everything's good to go. And then all you got to do now is git push. Now there are more pieces in here. I'm giving you the bare bones basics of this. And it's gonna ask you for your username and password really quick. There are better ways to get around this, but for right now, again, bare bones, completely basic. And git push will now push this code up to GitHub, okay? So now if I go back to my GitHub page, check this out. If I refresh the history, look at this. This is the commit message we just did. A brand new commit happened 38 seconds ago, okay? If we go look at the code, look at the file that I changed. It tells me this file was changed 1 minute ago, variables.tf. And if we go in here, my changes are now here, okay? So what's the workflow? I'm gonna give you guys a document for this that makes it super easy. Your workflow, your basic Git workflow is clone it first, get it on your computer, cool. Make a change, add the file, which is staging the file. So add the file, to say, hey, I now want you to go ahead and create a point in time history for this. Commit it. That actually makes the point in time save. Committing is the actual saving piece. Okay. Once you commit something, it is a part of the history. And if you wanna reverse that, you got to do special things to reverse that. Okay. So just be careful. Once you commit, you have now changed the history of the entire code base. Okay. You change the history of the code base. So now remember that change though was only local to your computer. It's distributed. So you have the full history. You made a change, but you made it to your computer only. And so the last thing you do is push. So make a change, git add, git commit, git push. That is the basic workflow. Git add, git commit, git push. Every time you need to make an update, do the same thing. Git add, git commit, git push. Now, the other piece of this is normally other people are working on this code base. And this is what I'll do? Yeah, let's do this really quick. Maybe I can show you. Do I have Git over here? I don't. Do I have Choco? No. Okay. Well, all right. So let's say someone else is working on this and I just push new changes to GitHub. The way that you would get those changes, the way that someone else would now get those changes, someone asked about it before, how do you synchronize changes? So, you'd be working on some stuff and you'd be doing some stuff and you say, oh, cool, I see the new code was pushed to the same code base that I'm working off of. And all I would do to get the new changes I would run a git pull, and git pull would pull down all of the updates. It would pull down those patches and it would apply those patches to my code base on my computer. And that's essentially how it works. A lot of little pieces there, but whenever you need to synchronize, you do a git pull. There are more pieces again here. This is your light introduction because git pull is actually a hybrid command. It actually does two different things, one easy thing and one that's harder to explain. It does a git fetch and a git merge. Merging is something we will talk about for sure. But there we go, git clone, then you edit the files, you add them, you commit them, you push them. That is the basic Git workflow. Now, you're probably gonna go off and you're probably gonna watch a YouTube video where someone shows you to do this. And I just really want to, they'll make a change to let's say they make a change to one of the files. And let's say at the very end of this file, I just put, poo-poo. Sure, wait, I made a change, no big deal. Let's go back in really quick also, and let's delete a line. I'm gonna delete a line really quick so that you can see. I'll delete that line, even though I shouldn't do this. I'll delete this line. I just want you to see what it looks like when you delete something or when you do a git diff. This is what a deletion looks like. A red minus, and an addition looks like the plus, just so you can see that. I don't know why I put poo-poo down there. But what people will tell you to do is this. They will tell you to do a git add dot. All right. This is what they will always, like almost every single tutorial will tell you to do a git add dot, or they will tell you to do, you can't do this the first time a file is new, or they'll tell you to do a git -am. Don't do either one of those things. Or okay, they're not bad. They're not bad. I don't want you to get into a bad habit. This is a very bad habit. The git add dot will add every single file that has been modified, whether you want it to be committed or not, to the commit. All right. And it's really annoying. It can be very problematic. I've messed it up a million times. Okay. Try not to get into this habit. While you're starting off, specify each file you want to add individually. If I did multiple files, so I made that one change to that file, and let's make a change to, let's do echo, some random letters. Whoops. Some random letters, and we'll put those into development.tfvars. I'll put some more. So that's a cool Linux thing you're going to learn next week. So now if we look at development.tfvars, there's some random text in there. I just push some text in there from the command line. No big deal. But if I do a git status, I've modified 2 files. You can add every file to a add command. So if I wanted to add them both, I would do main.tf and I would do development.tfvars, just with a space in between. You should do them individually, okay? Do not do the dot. I will show you when we get to this part why to not do a dot. I'll show you what kind of trouble you can get into by doing that. It's hard to unlearn. I did it for so long. Most people I know did it for so long. Just try your best. Until you understand what's happening, then you can start using it. But it's easy to make mistakes. Why red and green? Green is just, yes. That is what it's kind of supposed to denote. Green being good, red being bad. And that's usually deletions are bad. I know it seems a little weird because you may be trying to delete something, but it's also just a good visual indicator on what's happening. But yeah, 100% sure. That's 100% right. It is good and bad. Only case dot where git add IP. Yeah. Be brave and do the dot. Blah. So the dot is bad. It's not bad if you are sure that every file, if you're 100% sure that every file that's been edited needs to be added, go for it. Use that dot. But just be careful with it. Definitely be careful with it. What's up, Elliot? How are you doing today? Good to have you. Yeah, we're gonna get into rebase and all that. All that's coming later. This is not the Git course. We actually might run a I'll put out a poll. That first build series, it might need to be a Git session. So in Decoded, we are going to do a deeper dive into Git than we're doing now. We'll get deeper into Git here later, but they need to know it a little bit more than we need to know it here, like deeper than we know it here. I might run the tracks, the Git masterclass. I might run probably 50% of it on like a Saturday if anyone wants to come through and watch it, to kind of help people out, because I think I'm noticing that I didn't allot enough time for all of Git. But maybe we'll see. We'll see what happens. We might be okay. Oh yeah. Oh shit, Git is good. Sorry, I usually say we don't cuss on this channel, but that's just for I'm talking about the name of a really good tool. It's a good link. Definitely go to it. It's not someone trolling you. It's a good site that lets you know how to get out of some Git errors. This is why Git gets a little bit of a bad rap. It is a beast. I showed you a simple workflow, and everyone gets taught that simple workflow and thinks that Git is easy. Okay. When I'm not joking with you when I tell you that we actually had someone on here who worked at the company I used to work with, who did some of the hiring, and he said one of the things I do in an interview is ask someone how well they believe they know Git on a scale of 1 to 5. And if someone says 5, I know that you don't have that much Git experience. I honestly, and I will be right in 98% of the cases. If you say a 5, you're either one of the 2%, or you haven't had enough Git experience to know that you don't know Git. Okay, Git, it has lots of tools. It has lots of things to make you. It gives you a lot of tools to be able to fix problems, but there's a lot to learn. There's a whole lot to learn on how to use it properly. It is very scary. It can be scary. It can be. You can get yourself into some wild situations with Git, like wild situations. And again, imagine that 10 people are working on a code base and constantly committing code, imagine how jumbled that can get when patches are passed around and like resolving errors between merges and stuff. It can get really, really problematic, but we'll get there. We'll definitely get there. I don't want to introduce too much to you. So GitOps, I'll throw this in here right now just because we're going to spend a little time talking about GitOps, but you've probably heard all of the different DevOps variations, GitOps, DevSecOps, all that other stuff. Like, great. All GitOps is a way of doing operations being the management of systems like server management and, kind of managing the way that those servers work and the way that they're running, but it's managing them through purely Git, through version control. And so now that we can do, it's one of those things that's also been enabled by tooling. Remember, DevOps as a culture has been enabled by tooling. GitOps is one of those things as well. Because we can deploy and change infrastructure and perform ops, restart services and stuff via code, GitOps is the practice of having it all codified. So you have all your stuff done in code and you don't actually log into any machines or anything like that. If you need to make a change to a machine, if you need to install something, if you need to delete something, restart something, if you need to deploy new things, that is all done through a Git workflow. So someone writes some code, it is looked at by their peers, it is accepted, it runs through a CI pipeline, it gets deployed automatically without you having to do anything. So the operations is handled just for the most part, exclusively through Git, through a Git workflow, okay? And so that'll make a little more sense once we get into the CI/CD portion and you see how powerful CI tools are. But yeah, yep, one single point of truth. That's a good point. Like if you're always modifying the single point of truth, you know what's there, or at least you know what's supposed to be there. And so like, you don't have people logging in and making their own willy-nilly changes to systems and stuff. You always know what's going on. Okay. So it is, it's a pretty interesting workflow. Git, easy to use, easy to fall down 6 flights of stairs. That is an extremely true statement. All right, so we're gonna hold off on the last piece, which was the setup of the development environment. What's interesting is that the development environment setup is simply getting a text editor. All it is getting a text editor. I was gonna show you all how to connect VS Code. VS Code is my text editor of choice. We talked about this last night. I'll share some other options if you want. You can use whatever text editor you want for this course. Now, there's a reason why I'm not hand-holding on the text editor portion. This class has, yes, it's still for beginners. So if you don't know what a text editor is, that's okay. I can share some stuff with you or ask questions. I will share a link. If you hit !VS Code, it will give you a link to the one that you should grab. If you don't know what a text editor is, that's the one you should have. So let me, I'm pretty sure I put that command in yesterday. Did I really not put it in yesterday either? Hold on, no. It's got to be there. I'm sure I did it. Let me see. Commands, add. We went through this yesterday. Commands, add, !VS Code, and the website is https://code.visualstudio.com. Hold on. All right, try it now. Do it now. I don't, okay. Wait. Oh, it still works though. It still works. I spelled it wrong. I need to modify it really quick because I spelled HTTPS wrong. Put HTTPD, which is problematic. So let me fix that. All right. There we go. Now, if you do VS Code, you'll get the right link, and it'll take you to code.visualstudio.com. This is the best text editor. All a text editor is an application that allows you to edit text, but it specifically has tools to help you code better. Okay, That's all it is. That's all it is. So it's like Microsoft Word. You could try to write code in Microsoft Word if you wanted to. You'd have issues with formatting and all kinds of other stuff, but you could try. Microsoft Word is a text editor, but when people say text editors, or you might hear IDEs or integrated development environments, these are tools specifically written to help you write code better. Download VS Code is the one you want to use. The only setup you need is VS Code. That's it. That's really it. If you want to follow along the same way I am, I shared a little link in here with a walkthrough for getting a remote development environment set up. Okay. Here's why I shared this. You do not need to do this. This is completely optional. I stated up here that it's optional. I recommend those of you who are brand new to this stuff to do this. The reason why is because all of us are working off of different systems, most likely. I'm sure there are plenty of Mac users here. I'm sure there are plenty of Windows users here. I'm sure there are maybe a handful, maybe not in the beginner course, of Linux desktop users. Okay, so you have possibly one of 3 different operating systems you're working off of. One, Visual Studio works on all 3. That's one reason why it's amazing. That's great. But the things that we are doing, the things in the tech industry that you need to know Linux, okay? So the tools and things, we're gonna be spending a lot of time in the command line. That's why we're spending a whole week learning Linux. And that's why that week is next week. It's so early in the boot camp. If you are, if you're on a Mac, you're probably going to be fine. Mac is built on a Unix kernel. It is a Unix-like operating system. Linux is also a Unix-like operating system, but there's some caveats in there. I know people are gonna get all out here with the GNU and all stuff. It's still legally a Unix-like operating system, but it is a different kernel. So Linux and Mac are pretty similar in this aspect. They're going to use different tools to install things, but all of the things from the command line, their file structure, their directory structure, the way that you, the shell that you have available to you, the way the applications are installed is going to be very similar. Okay. So you're probably going to be fine because I'm going to be in Linux. Because we're going to be doing Linux commands. For people on Windows, you have options for this. Linux is so important that Windows ships with a Linux kernel. You can install the Windows subsystem for Linux. If you're comfortable doing so, I highly, and your computer allows for it, I highly recommend that you do it. It's called the Windows subsystem for Linux. All you gotta do is type in how to install WSL. And it'll give you a link and it will take you through installing it. Now, it's really only like 2 commands, but everyone's computer can't do it. All right, that's a problem. Oh, so Choco, but Choco is just a wait. Can you use Choco to install WSL? I love Choco. I mean, I do love Choco. Here's the problem: you can use Windows. You can use Windows for this. You really can use Windows for this entire course. The issue is going to be when we specifically get to file pathing. Okay, we're gonna get to that next week. All right, we're gonna get to it next week. If you aren't well versed already in file pathing, you are going to be very confused when we are moving around the computer, because Linux and Unix file pathing and Windows file pathing is different. It is similar, but it is different, and there's some oddities in the way that you interact with them, and it might be difficult for you to understand those nuances, to be 100% honest. So that you're doing the same thing that I'm doing, that is why I recommend to either use this Linode server, or it doesn't even need to be the Linode server. It needs to just have access to some type of Linux environment. If you're familiar with virtual machines, that works. WinGit with Winsu. Yeah, so I know WinGit is a package manager for Windows coming out, which is going to be pretty dope. Oh, dope. That's pretty dope. I love it. Yo, #Friday. What's up, man? Appreciate the gifted sub. That's love right there. Sorry I haven't been in the Discord. I've been, been making this the first part of this year pretty special. You know, I'm a wake up at 4:30 type of guy right now. But I appreciate the love, man. I really do. But yeah, so this is why I recommend it. And also, yes, you can use DigitalOcean. Absolutely. The only reason that I'm choosing Linode is I genuinely use a Linode VPS, and they are a channel sponsor, or they were a channel sponsor, and you can get 100 credits for free. I want you to have to spend $0. I really do want you to have to spend $0. And so that's the reason why we're using this. Any Linux system will do, but you know, it just goes through this. If you want to use that, use it. I call out right here, you know, any, do I call it out here? Yeah. Although this is a guide for a Linode VPS, if you have a server, or if you have a system that you can connect to via SSH, use that system. Okay. If you have no idea what we're talking about, you should probably do this. Or if you're on a Mac, you're fine. If you're on a Mac, don't even worry about it. To be 100% honest. If you're on Windows, if you're comfortable installing WSL2, do it. If you are like, I don't know what that is, and I don't understand how to, like, I'm looking at this guide and I don't understand what's happening, don't do it. Okay. Correct. You can. So I do think you have to put in a credit card, but you do not have to put any of your money in. It is not spend $100, get $100. It is you get $100 worth of credits, and it will use them all up. The servers are only $5. They start at $5. I recommend using the $10 one, to be honest. So you'll get to use it for 10 months. So you know, this class is only 2 months, and in between there's a month off. So you can shut it down and you can retain all your credits. You can do an entire year and a half of classes without paying a dime. That is the main reason. Someone claimed that their code didn't work, but other people said it did. If it didn't work, you can just go there. Like, if you just look at Linode, you can get, I think if you just sign up, you can also get $100 credits. There's like, if you just Google like Linode credits, you can get it. If not, you can also get a code from the Primogen. Well, you should have followed him when I told you to follow him. There's a couple other streamers on here you can get it from as well. You know, my goal is simply to help you have it. I'm not pressed over. I don't get anything for it at all. So just, yeah, I don't get anything for it. Just letting you know about it. Oh yeah, just use my credit card to start out. Sure. You know, I mean, it's gonna get declined, but you know, I mean, come on, guys. I don't have a job right now. You know, I'm self-employed. You know, so it's gonna get declined. No problem. You can use mine. But yeah, whatever works. Raspberry Pi, excellent option. Raspberry Pi is actually a phenomenal option. But again, there's levels of tech. You know, everyone's at a different level. Don't feel weird that everyone's throwing out all these options and you're like, yo, what the heck are all these? Don't sweat it. That's why I wrote the little guide for you. You're gonna be fine. I promise you're gonna be fine. You don't need anything special. You really don't need anything. I'm just trying to make it as easy as possible for you. But that's it. But it sounds like, you know, everybody knows some pretty cool stuff. I actually have some Raspberry Pis to give away that I did not give away last time because I forgot that I had them. And I just remembered that I had them because you brought up Raspberry Pis. So I will find them. I have like 3 or 4 Raspberry Pi 4s, 2 that were given to me and 2 that I bought to do some giveaways. So I will find them. And when I find them, I will give them away. So yeah, I mean, I don't know what the stipulations will be. We'll make it fun, but for sure, I'll give them away. Because Raspberry Pis are great. It's a good way to just mess around with something and have some fun. You have cash on your points card to speed the charges? Oh, I don't know. It's a good question. Do they take back your rewards? Probably. But that's why you spend the rewards first. You know? Does that have Wi-Fi? Oh, no, that's for the $5 one. That's a good question. It probably doesn't have Wi-Fi for the $5 one. Yeah. But cool. Yeah, we don't, like I said, today was a weird day. We talked about a lot of different things, but still relatively light. I know we dove into Git, and you know, you may have been like, oh, like I didn't really understand what's happening. I was not teaching. Tonight was not intended to teach you Git. It was designed to just, you know, to dip you in the water a little bit with it. So don't sweat if you're like, oh man, that was really fast, and like he didn't go thoroughly in over that at all. I promise you, this will not be the case when we start Linux next week. Now, I do want you to come prepared next week. If you are brand new to Linux, it is going to feel like we are moving very quickly. But I will tell you this, you will get instant feedback when using Linux, and you will feel like you're doing something. You will feel powerful next week, especially if you've never done anything with Linux before. You're gonna feel extra smart, and it's gonna be pretty easy to do. It's been pretty easy, but we're gonna touch a lot of things. Okay, so it'll be fun, but come ready to really dive into it, because we're gonna try to learn a lot of Linux concepts in a week. Like, I'm really gonna try to teach you a substantial amount of Linux administration in a single week, and I think we can get through it. I think we can get through a lot of it, so that you're able to use a Linux server full time. Like, you will be able to hop into a command line, and you might not be fast. You might have to go look up a command, but you're gonna know. You're gonna have learning about, okay, cool. Well, I know that I can move around to this directory. I know that if I want to rename this, I can rename it. I know that if I want to see how much memory there is, I know there's a way to do that, and I can just Google how to get memory, and then you'll see the command that we did, and you'll say, oh man, I remember that, and I'll type that in and do it. You will learn a bunch of commands. You will understand how a Linux system works, and yeah, it'll make you a better engine. It'll set you on your way. I'm not joking. Linux as a foundation is valuable. You can get a job just on being good at Linux. All right, and that is not an exaggeration. You become good at Linux, you can get a job just on that 100%. Like that. So it's funny, because that's usually my recommendation when people are seriously like, look, I know the journey can be long. What's my fastest route in? What is my fastest route in? And depending on people's backgrounds, especially for you people doing help desk, all of you who said you had help desk roles, learn Linux. Learn Linux. It's hard right now, because I'm kind of on the route where I'm like, well, cloud, but I think it's hard for you to be good at cloud without learning Linux too. So learn Linux. But that's it. That's all for tonight. Let's see. Yeah, so that's it. I will see people back tomorrow for Decoded. Now, if you want to get a little primer on Linux, tomorrow in Decoded, we are doing, what are we doing? We're doing a little bit of Linux. Why are we doing a little bit of Linux? We are doing a little bit of Linux tomorrow because you can't really run your code without knowing a little bit, without knowing how to just get around. So we're not diving that deep into Linux tomorrow. We are simply diving into the different commands to it's command line navigation. How do you move to different folders? How do you move files around? That's all we're going to be learning tomorrow. A little bit of Linux. We're also going to be learning a little bit of Git there tomorrow too. So we will learn what we learned tonight, but tomorrow we will actually go more in depth than we went tonight on Git for people in Decoded. So if you're interested in that, there will be like things for you to try with Git. We'll all be trying to commit to the same repository and stuff tomorrow. But yeah, that's what we're doing tomorrow. If not, I'll see you on Friday if you want for the Horizons, the start of Horizons, Cloud Computing with AWS class. That is at Friday. It is an hour earlier than everything else. Everything else during the week starts at 7 p.m. Eastern time. That class, because it's one day a week, starts at 6 p.m. Eastern time. So just, keep that in mind if you're interested in doing it. It'll be a little bit longer. But we'll learn a lot on that day, a whole lot of stuff actually. Like, we're actually covering a substantial amount of topics, so it's gonna be tough to get through, but we're gonna make it. We're covering all of this. Woo! We're gonna get through it though. I'm gonna time it all. They're all gonna be about 20 minutes, just to get an introduction to. So that'll be it. The next class for this Ammonia Flows is Monday. Monday is the next class, and this is all Horizons is. This is the level 1 course for the cloud as well. So yeah, yes, this is, will you be ready for a cloud role? I think out of all the classes, the cloud course is the one that'll get you the closest to being ready for an actual role. Maybe it'll give you enough, certainly to pass your cloud practitioner exam. It'll give you right under enough to be able to pass your solutions architect associate. You'll have to dive into it a little bit deeper to be able to pass that. But this level 2 of Horizons, going through level 1 and level 2 of Horizons, you'll be ready for a cloud role. You can be ready for a cloud role especially if you know a little bit of Linux already. You will be ready for a cloud role. Level 2 will definitely get you ready for the solutions architect associate for sure. Definitely get you ready for solutions architect associate, and it'll prepare you heavily for the solutions architect professional. And the third level is designed to be a full Solutions Architect Pro course, which is, it's pretty deep. It's really pretty deep. So yeah, that's what we'll be doing. That's it. Let's see who's online tonight. Excuse me. Who are we gonna go see?
We are.
I think we can connect.
Also,
I think
if you
you're right.
Have anyone you ever want me to?
I think we can
raid,
connect.
let
I
me
think
know.
you're right.
All right, Chris. See you tomorrow.
I think we can
Raid.
connect.
Everyone,
I
again, like I said,
think
take
you're
care of your mental. I know lots going on right now. You know, don't sweat it. I know lots going on right now. All right, we'll head over and say hello to Rockstar, who is also an Only Dev team member.
Our internet connection
What are they
is so
doing
important.
tonight?
We're working
Thinking.
from home,
They're
school
thinking.
from
So
home,
that's what we're
dating
gonna head
from
over to
home.
see. Peace out, everyone. Thank you so much for all the love. I genuinely appreciate it. I will be reaching out to Nika Codes. Nika Codes, if you're still watching, you're probably not, but please send me a whisper. I'd love to. I'm going to send you, send me your email address so that I can send you the type form so that you can get your socks and so that you can get your stickers as well. I really do appreciate it. We love everybody. Again, keep up the energy. You know, it's a long time until I see you next. Come in ready Monday, you know, with bright eyes and bushy tail. And we'll get good. We'll get good. We'll spend 2 hours, and after 2 hours, you'll be like, man, I'm a pro at all the things that I do. But perfect. Studying for the CSA right now. That's dope. That's dope. Good luck. I think you got it. So let's go /raid. Who we're rating again? Oh man, see, I'm a bad typist, and they got some weird letters. Rocks K star 74. Man, I suck. Okay, now we're out of here in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.